Hey there, and welcome. Today, we're going to pull back the curtain on the tech we use every single day. We're going to uncover the secret recipe for what makes an algorithm truly good. So, let's get into it.
You ever stop and think about this? You pull out your phone, pop in an address, and boom, it just knows the fastest way to get there, dodging traffic in real time. How on earth does it do that so perfectly, every single time? Is it magic?
Well, it's not magic, but it's pretty darn close. The real answer is a well-designed algorithm. You can basically think of an algorithm as a recipe, a super precise, step-by-step guide to solving a problem. And these recipes are the brains behind just about everything: your GPS, your search results, even your social media feed.
But, just like with cooking, not all recipes are created equal. A really good algorithm, one you can actually build reliable technology on, has to have 4 essential qualities. Let's break them down.
Okay, first up, it has to be deterministic. This is all about predictability. It just means that if you give the algorithm the same ingredients, the same input, you have to get the exact same cake, the same output, every single time. No surprises, ever.
So let's go back to your GPS. If you ask for the route to work at 8 a.m. and nothing about the traffic has changed from yesterday, it should give you the exact same best route. That's determinism. It's what makes technology trustworthy. Second, the steps have to be unambiguous, and that means every single instruction has to be crystal clear. There cannot be any room for guesswork or interpretation. A computer doesn't just get what you mean, right? You have to tell it with absolute precision.
I mean, can you imagine if a step in the recipe said, turn somewhere around the next corner? That's totally useless. It has to say, turn right at 123 Main Street. Every single step needs to be that clear and precise.
All right, number 3. And listen up, because this is hands down the most important quality. The algorithm must be correct. And this doesn't just mean it works on the couple of easy examples you tried. It means it has to produce the right answer for all possible valid inputs.
Just think about it. If your search engine only gave you the right results on, say, Tuesdays, it would be worthless, wouldn't it? For an algorithm to be correct, its reliability has to be absolute across every single scenario it could possibly face.
And finally, our 4th quality, scalability. This one is all about how an algorithm handles pressure. What happens when the amount of data you throw at it goes from 10 items to 10 million? A scalable algorithm stays efficient. It doesn't just grind to a halt.
Let's circle back to our navigation app one more time. Finding the best route across your town, that's one thing. But can that same algorithm find the best route from New York all the way to Los Angeles without taking, 3 hours to think about it? That is the question of scalability.
So, we have our 4 qualities: deterministic, unambiguous, correct, and scalable. But are they all on the same level? Oh, absolutely not. There is a definite pecking order here, and one rule stands high above the rest.
It all comes down to this simple but incredibly powerful idea. A fast wrong answer is still wrong. It doesn't matter how slick or how fast your algorithm is if it gives you the incorrect result. The absolute key is to focus on making it correct first. You can worry about making it faster later. Okay, so now we know what makes an algorithm good, and we know that correctness is our #1 priority. So how do you actually build one of these things reliably? Well, you need a plan, a blueprint, to go from a fuzzy idea to a correct solution. Let's walk through the 7 steps to get it right.
And hey, before we dive into the steps, I really want you to hear this. This is not just for software engineers. This is a framework for clear, structured thinking. It's a way you can tackle any complex problem by breaking it down logically so you don't miss anything.
So here's the blueprint, and the first thing you should notice is that writing code is the very last step. First, you just restate the problem in your own words. Why? To prove you actually understand it. Second, you get super specific, what data is going in and what result needs to come out. Third, you figure out how to organize everything. Then, step 4, you write out the logic in plain English. We call that pseudocode. It's only after you've tested that logic with a simple example and checked for those tricky what-if scenarios that you finally get to write the actual code. This process is what builds reliability right from the start.
Let's really zero in on step 6 for a second, checking for edge cases. I'm telling you, this is where so many great ideas fail. These aren't just an afterthought, they're a core part of the problem. You have to be asking these what-if questions. What happens if there's no data? What if there's just one piece of data? What if there's a tie? Thinking about these situations is what separates a fragile algorithm from a really robust one.
Whew! We've covered a ton of ground, huh?
from the core qualities of a good algorithm all the way to a practical plan for building one. So let's bring it all home and lock in the most important things to remember.
So here's the bottom line. A good algorithm has those 4 key traits we talked about. Above all else, remember that correctness is king. A fast, wrong answer is still wrong. And by following a structured plan, like the 7 steps we went over, you can avoid guesswork and make sure you're designing for those tricky edge cases from the very start.
So I'll just leave you with this to think about. This methodical way of thinking isn't just for computers. Think about your own work, or even your daily life. What problem could you solve better if you just took a moment to design a clear, correct, and unambiguous recipe for it first? Thanks for tuning in.